We've spent a lot of time talking about consumers. Now it's time to turn our attention to the production side of the market. Firms have to answer a lot of questions when they're making choices: how much to produce, what inputs to use to produce it, what price to charge. We're going to be addressing all of these questions in this section, but first we're going to start out talking about how to model production using different inputs. So begin using a production function, which is probably something that's new to you since intro econ, but is a really important part of studying economics going forward. So our production function is a mathematical equation that describes how we transform input into output. And we have lots of different types of inputs in economics. So here we've written an equation of Q, quantity of output, as a function of a number of different categories of inputs, which I'll define here briefly. K stands for capital, L stands for labor, H I'm going to use to stand for human capital, which is like the skills and education and productivity of workers. And N for natural capital. Those are our natural resources. So what we want to do is define an equation that transforms inputs into output. These are broad categories of inputs. Obviously, in reality, each specific firm is going to use different types of inputs. In general, we are going to have production functions with two inputs in order to draw an important distinction between different types of inputs in the production process. But let's start with a production function for just one input, so we can just start working with production functions and understanding how to characterize them. So we've got an example here of a simple production function. Q equals the square root of L. We've just got one input, labor, and we want to start to think about what that production function looks like. We can do that by plotting the production function. So I've got some numbers here that are easy to take the square root of. 1, 1, 4, 2, 9, 3. Okay, oops. And you can see that our production function here has a concave shape. It's increasing at a decreasing rate. Okay, and that's an assumption that we're going to be making, and we'll kind of outline what that is and why we're making that assumption here in a couple minutes. Here we have just one input, so we can plot the production function on this two-dimensional graph. But when you have more than one input, you're not going to be able to do that. And so what we want to do is calculate marginal product to help us think about the relationship between each input and production. So marginal product is the additional output gained from one additional unit of an input, in this case, labor. It's the slope of our production function. As we move over one unit on the x-axis, how much does production increase? And so to calculate that, we're going to take the derivative of the production function with respect to labor. Remember that this production function could be written as L to the 1/2. And so our marginal product in this case would be 1/2. L to the negative 1/2, or 1 over the square root of L. So to plug that plug our numbers into our marginal product equation, right, we've got 1/2 times 1 over basically Q. And so that's going to give us 1/2. 1/2 times 1/2 is, oops, 1/4, and 1/2 times 1/3 is 1 1/2, 4 1/4, and 9 1/6. Okay, and again, you can see this is the slope of the production function. So, I mean, we already plotted the production function. We kind of know what it looks like. Production function is increasing here at a decreasing rate. So that means I have a positive marginal product, but it is declining as I produce more. This is a law of diminishing marginal product, and it's an assumption that we're going to make for all production functions that we use. And the assumption here is that as we increase one input, holding the others constant, our marginal product will decrease. Now, production functions don't necessarily have to be strictly concave for every level of production. In reality, you might have at first a production function where you have increasing marginal product, okay, then decreasing marginal product, and then even negative marginal product. So in reality, it's possible that our production function could look something like this. And you'll notice here I said this is increasing marginal product because you can see the slope of the production function is getting steeper as I produce more. So if I were to graph my marginal product, okay, it's positive and increasing. Then here I have decreasing marginal product. And then eventually my marginal product becomes negative. The point of the law of diminishing marginal product is that eventually, as we add more and more of our input, eventually the marginal product will be decreasing. At first it might be increasing, but eventually it will be decreasing. And why should that be true?
To see why this is true, imagine that you're running a small bakery with one baker in a small kitchen with, say, 2 ovens. The baker, because she's by herself, is limited in the number of tasks she can take on. She will prioritize the most effective tasks to be the first, or in other words, the most profitable tasks will be performed by the first unit of labor. You may find that it increases profits to add a second baker. The second baker will complete additional tasks that are maybe slightly less profitable, but still add to the profitability of the business. In addition to the fact that firms will allocate resources primarily to the most profitable tasks first, we can also understand this assumption or this law in terms of how crowded the fixed input becomes. Here, we're only talking about labor, but in reality, we have lots of different inputs into the production process. And it's important to recognize that when we calculate marginal product of labor, we are assuming that we've held constant all of the other inputs into production. So in your bakery, as you add the second baker, the third baker, the fourth baker, etc., your small kitchen, your capital investments, may become crowded, meaning that the productivity of each additional unit of labor decreases.